In the current industrial practice, amine absorption technologies are used for CO2 capture from flue gases that typically contain 15% CO2 and 85% nitrogen. Potential reduction in energy consumption is achievable by use of PSA technologies that are conducted in fixed bed adsorption devices. A number of microporous crystalline adsorbents such as zeolites and MOFs can be employed in fixed bed adsorbers. For post-combustion CO2 capture, NaX zeolite, known commonly by its trade name 13X zeolite, is considered to be the benchmark adsorbent with the ability to meet the US Department of Energy targets for CO2 purity and recovery. 13X zeolite has the faujasite topology that consists of cages of 786 cubic angstrom. Each cage is separated from adjacent cages by 12 ring windows with an opening of about 7.2 angstrom. The CO2 binds selectively with the extra framework cations of sodium X zeolite that has a silicon to aluminum ratio of about 1.2. Per unit cell of NaX zeolite, they have typically 86 sodium cations. MOFs such as magnesium MOF 74 and copper BTC are also candidates for use as adsorbents in PSA technologies. For further information on the use of 13X zeolite and magnesium MOF 74, see other YouTube presentations on my channel. More recently, the potential of MOFs for CO2 capture from ambient air has been the subject of a number of investigations. Typically, the CO2 concentrations in ambient air are about 400 ppm. Higher concentrations up to 500 ppm or more are encountered in confined spaces such as in aeroplanes, submarines, space vehicles, and inside spacesuits of astronauts. There is anecdotal evidence of the curtailment of a spacewalk due to the increase of CO2 levels inside a spacesuit that uses canisters containing lithium hydroxide for CO2 capture. Anyone who has seen the Ridley Scott film, The Martian, will recall the long spacewalk Matt Damon undertakes towards the end of the film in order to link up with Jessica Chastain in her spacecraft. For CO2 capture from ambient air and in space vehicles and submarines, the use of functionalized MOFs is the way to go, as we shall see in the next slide. Strong selective binding of CO2 is achievable with MN magnesium 2 DOBPDC, an amine functionalized MOF developed by Professor Jeffrey Long and associates at the University of California in Berkeley. Comparison of various candidate adsorbents for CO2 capture from ambient air shows that this amine functionalized MOF has the best uptake and selectivity as compared to other candidate adsorbents. For further details, refer to my publication in Separation and Purification Technology 2018. This is the reference.